Hey, listeners, before we get into this episode, we have some fantastic news. You know, my K-12 Developing Mathematical Reasoning, Avoiding the Trap of Algorithms book came out earlier this year. Super excited. It hit top new release and bestseller. Ow! Well, I'm even more excited to announce that the grade band companion books are about to be here. The K2 companion book, Developing Mathematical Reasoning, Daily Strategies, Tools, and Activities to Teach the Big Ideas in K2, say that 5 times fast, is coming out soon. And we are having a launch webinar on October 8th at 7 p.m. Central, 8 p.m. Eastern, 5 p.m. Pacific.
And you are all invited to celebrate with us, especially K2 teachers and coaches and math leaders. Pam is going to share tons helpful things to teach K2 math that is more figure-outable.
Yep, I'm going live on October 8th to show you how you can get the most out of teaching our youngest students to math in all the best ways.
You're going to want to join us. To register, go to mathisfigureoutable.com/DMRK2 webinar. We'll see you there.
That's mathisfigureoutable.com/DMRK2 webinar. Now on to the episode. Hey, fellow mathers. Welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figure-Outable, we are on a mission to improve math teaching.
We know that algorithms are amazing human achievements, but they are terrible teaching tools because mimicking step-by-step procedures actually traps students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
And we invite you to join us to make math more figure-outable. Dum-dum. Hey, Kim.
Hey, we kind of just jumped on today and didn't really shoot the breeze at all.
We didn't even say hi or anything. How's it going?
It's good. How are you?
You're very pink today.
I am. I know. We should tell listeners that
I feel like you don't wear pink very often.
I don't. And listen, we've been telling people that we don't see each other, but we recently made a switch.
Yeah, so I think people think we're in the same room when we record, and we're not. You're at your house, I'm at my house.
Mm-hmm.
But we have turned on the video so we can actually
just recently. Yeah,
just recently. So whether that's good or bad, we didn't do it at the beginning very purposely, right? Because we weren't convinced that if we could see each other, that we wouldn't describe well enough, so that audio, we would assume you'd nod, I'd wink or whatever. I don't wink, but whatever.
We wouldn't say enough because we'd nod like, I got it. You can move on.
Exactly. Yeah. So we purposely didn't have video on so that we would make sure that everybody could understand what we meant. We would describe enough, right?
Yeah.
That's going to be part of our trick today, I think, in our episode, is to make sure we describe enough.
Now we just make faces at each other. All right, let's get on with it. Okay, so listen, several months ago, I mean, it's been quite a while, Mather in CO, I'm hoping Colorado, Mather in Colorado left a review, and the title is A Must Listen Weekly, 5 stars, fantastic. And they said the best math education podcast out there right now. Ooh. Learn real math yourself and then have fun teaching it with your students.
And fun is in all caps.
I know, nice. Great. And Mather, I sure hope that you still think so. It's been a while. Thank you for listening and for giving us a review.
Yeah. The way the algorithms work, the more reviews you get and the more if people will rate, then it shows it to more people, and then we can spread the word that math is figure-outable to more people. So yeah, thanks, Mather in CO. I like it.
Colorado. Mather. I need to be in Colorado right now.
It's pretty, isn't it?
Oh, yeah. So nice. Okay. So this is a special episode because we often, like super, super often, get asked by our journey members and leaders about the best problem string to do with teachers. What's the one? And there are a few go-tos, but a favorite by far is one that we affectionately call sticks of gum. In fact, when we call it that, people who have heard you mostly know exactly what you mean, but it really doesn't refer to the math that's happening. So for you leaders or for teachers who are wanting to share with your colleagues, but haven't ever had a chance to hear Pam walk through the string and describe her choices, this episode is for you.
Yeah, so sticks of gum. Yeah, when our coaching people say, "Hey, sticks of gum," when we refer to that, it's because for a long time I used the context of a pack of gum having so many sticks of gum in it. Lately, I've done bags of M&Ms, but it has everything to do with one carton or container or box or bag having so many items in it. And yeah, for a long time, I did sticks of gum. So hey, Kim, just for nostalgia's sake, we'll do sticks of gum today,
Okay.
even though I've been doing M&Ms a lot lately. So I would say to people, hey, have you ever, anybody chew gum, whatever, have a brief conversation about gum. And then I'll say, can you picture a pack of gum that has 27 sticks in it? So they're the long, skinny, kind of bendy, not the fat squat, and I do enough conversation about it so that people can kind of picture the pack. It's not about real world. It's really about just having people be able to sort of realize what's happening. I want them to be able to picture this pack of gum, and then I'll draw a table wherever I am on the whiteboard or on my iPad or whatever, and I'll write bags. See, I'm in bags of M&Ms. I'll write pack and then sticks. So above the one column on the left, I'll write pack, and I'll write sticks in the right hand column, and then I'll put one pack has 27 sticks. So I have a table now, packs, sticks, 1 to 27. But as I'm writing that, I'm talking about the story about gum. I might say something about who chews gum. Raise your hand if you chew gum. I'll even sometimes say, I think it's the one with the stripes on it. And then people will like, oh yeah. And then they'll tell me brands. And so not a long time, but enough time to get sort of some context, get kids kind of in the story enough that we're like, oh yeah, we're talking about a pack of gum. And then I'll say, well, okay, so if one pack, you can picture it, one pack, remember long, skinny, kind of bendy sticks, not those fat, squatty ones. If one pack has 27 sticks of gum in it, how many sticks would two packs? And then I'll write the two. So as I said, how many sticks would two packs have? I actually write the two underneath the one. So far I have a table, pack, sticks, 1 to 27, and then two. And then I'll just sort of wait. Now, I'm not going to wait too long on this one because if I'm doing this string, kids are going to be able to double 27 without too much stress. It's not a speed game, but we've talked about before, we want to have problem strings be kind of snappy, right? So I'm going to say how many sticks would be in two packs, and I'm going to kind of watch. I'm going to look at students, and as soon as enough kids kind of light up, I might ask them, give me a thumbs up when you know the number of sticks in two packs. As soon as enough kids have chewed on that just enough, then I might even say, just say it out loud, everybody. Or I might turn and whisper shout to the person next to you, how many sticks in two packs? Just kind of get everybody going for this first one. People will often say 54. And then when they say 54, then I'll say, oh, so if you double the number of packs, and then I draw kind of an arrow between the 1 to 2 packs, and next to it I'll write times 2. Then you double the number of sticks, and I'll write an arrow from the 27 to the 54, and I'll write times 2. So I'll say, so if you double the number of packs, then you double the number of sticks as I draw those scaling arrows, and I'll say, and that got you 54 sticks. Then just recently, I've added a little bit of a line here where I want people to tell me how they were thinking about doubling 27. And the line that I've kind of added recently. So if you haven't heard me do sticks of gum in a hot minute, here's a little bit of a new twist that I'll say. I'll say I don't. A lot of you just said 54. I don't think that 2 times 54 was one of those flashcards that you memorized in third grade.
You mean 2 times 27?
Oh gosh, 2 times 27.
Yeah,
Thanks.
yeah.
Woo. I don't think that was a flashcard that you memorized. It wasn't a fact that you like drilled. So I think your brain had to do something. Most of us, your brain had to do something to double 27. What did your brain do? And I'll pause just a little bit, and then I'll say, did anybody think about doubling 27 as doubling 20? And then I'll just trail off. Did you double 20? And I'll look. So right now I'm trying to pull out one of the major strategies, one of the important strategies for doubling 27. So Kim, if I were to ask, somebody, hey, did you use 20? What might that person say if they use 20?
They probably said I doubled 20 to get 40, and then I doubled the other 7 to get 14, and then I added 40 and 14 together.
Nice. To get that 54.
Mm-hmm.
So since we're talking about facilitation moves, you might find it interesting that often they'll say, well, I doubled 20 and I doubled 7. as if that's enough.
Mhm.
So then I will say, and double 20 is,
Mhm.
and when they say 40, I'll write down. So I have now written down off to the side, 27 equals 20 plus 7. And as I then pull out of them, double 20 is, then, and they say 40, I'll write 40 down below 20. And double 7 is, and they say 14, I'll write 14 below the 7. And then I'll say, and 40 and 14 is, and then they'll say 54. So I'm gonna represent, model what they just were doing. But what's interesting to me is how often I have to actually pull out of them more than they were gonna say.
Mhm.
Like they'll just say, well, you double 20, you double 7. I'm like, well, what is double 20? What is double 7? Oh, and then you added those together. Similarly, then at that point, I'll say, did anybody not use 20? And almost always people in the room will kind of smile and nod. And then I'll say, did anybody use 30? And I'll kind of trail off. Now at this point, many people who were just smiling like, oh yeah, I did something different, actually then go, oh no, I didn't use 30. Often people will use 25,
Mhm.
which is a fine strategy. But for my purposes in this string, I'm actually not going to pull out the 25. And so Kim, don't let me forget, I'm going to talk about why in just a second.
Okay.
I want to pull out the 30. And so then I'll look. And if nobody is sparking on the 30, then I'll say, could you? And almost always, in fact, I don't think it's happened yet that someone hasn't sparked then. When I say, could you? Someone will raise their eyebrows and go, well, and if it's just enough, I'll go, ooh, tell us about that. And then I'll call on that person. So Kim, often when I call on a person, how could you use 30 to double 27? What might a person say at that point?
Yeah, so they'd say I doubled 30, and if they were listening when you pulled out the double 20, double 7, then they'll say, and that was 60,
Hmm.
and then I doubled 3, and that was 6. So then
And I'm going to
60
pause you
meant
there. I'm going to pause you there because I would pause the person as well.
yeah.
I would say six, six. Where say in fact, if I can even back up just a little bit, when they say 30, if oh, should I even? Sorry, if I didn't have to pull it out of them, if somebody actually did use 30, I'll say use 30. 30's not even in the problem. Like I'll kind of push back a little bit, and sometimes
Mhm.
people will be like, they almost get flustered. What? Well, you asked if I use 30. I'm like, well, I know, but it's not even in the problem. They're like, I know, but it's like almost 27. So when you said that I was going to subtract 3, I would usually pause the person and go, whoa, where's this 3 coming from? Just so they can say, well, 27 is 30 minus 3. And then, like you said, double the 3 to get 6. And then I cut you off. Sorry.
Yeah,
60
it's okay.
minus 6 is
54.
also that 54. Cool. So now I have off to the side these two ways of thinking about doubling 27. And I'll often say, so nice. These are two of the major four. Oh, now I should be clear. If I'm working with teachers, I will say this part. If I'm working with students, let me do students first. If I'm working with students, I'll go, nice strategies, you guys. Nice way of using what you know to think about doubling 27. Cool. If I'm working with teachers, I'll say, hey, teachers, you might find it interesting. Here are two of the major four. There's only a few of the major four strategies that we want to build in kids to really think and reason about addition. These are two of the, there's only a few, because I want to help teachers realize there's only a small set. But Kim, that just made me think, should I be focusing on facilitating this with kids or
Yeah, so
teachers or both?
I've actually been sketching some notes. So what we said was that this would be a great one for leaders to do with teachers and for teachers to do
Okay.
with their colleagues. But I think we could go either way, but I did write down student and I crossed it out and wrote teacher because I wanted you to mention the idea of 17 versus 27 and for how
Mm,
long you would do this additive bit if you were working with adults versus working with students. Because I know it sounds like you were talking for a really long time. And part of that is just for the purpose of the podcast to really parse out all the moves and the questions.
yeah.
But with students, it really does not take that long.
No, in fact, at this point, I'm maybe 2 minutes into the string.
Yeah.
If
Yeah.
maybe not even that. Like it's
Yeah.
pretty quick.
Yeah.
I'm keeping it snappy.
But with
Yeah.
teachers, it is a bit longer because you are pulling more and you're solidifying the idea that this is just a few of the major strategies. You in
Mhm.
general, I think you have talked a lot, maybe even on the podcast, about taking longer with adult strings because you don't get to see them very often. And you
Hmm.
want to bring in the mathematics, but also the moves that are being made.
Hmm. Yeah, very true. Very true. So, just so I'm clear moving forward, can I talk about both students and teachers, or do you want me to focus on if we're doing it if a leader's doing it with teachers? You
Hmm.
should see the look on my face right now. I'm like,
Let's do because we have fantastic problem string books that teachers can grab. Let's go leaders with teachers
okay, okay, because
or
then you could go
teachers with
look.
their colleagues. Yeah.
Gotcha. Okay, so teachers with colleagues. So we now have on the board pack sticks 1 to 27, 2 to 54 with these scaling arrows. I'm going to then say, okay, cool. We've got the number of sticks in one pack, the number of sticks in two packs. How about the number of sticks in four packs?
Mhm.
And at that point, I will let people think. I've written down the four. I'm going to go erase those scaling marks times two on both sides. So I've
Mhm.
kind of cleaned up the ratio table a little bit. And now all you've got are sort of the 1 to 27, 2 to 54, 4 to blank. Let people think. Now, I'm going to go really fast here because nobody needs to think about doubling 54, like very rarely. So when I say 4, I erase the scaling marks. I'm instantly going, y'all, that's not, we don't have to wait very long on that one. Just say it out loud, everybody. And then they'll just say 108 because double 54 is, now at this point, I'll pause a little bit and I'll go, okay, so did you do the same thing? Did you scale times 4? And I'll draw the scaling arrow and then the times 4. And then people are like, no. And I go, or were you kind of looking to be lazy? I mean, efficient, because mathematicians often seek to be lazy. I mean, efficient. So I'm trying to joke a little bit here. But I'm also trying to help people realize that this instinct they just had to just double the two packs is a good instinct, that it's a mathematical behavior to want to be efficient. And I'll joke a little bit about how it's lazy. So then I'll erase those scaling times 4. I'm just drew that really quick. And I'll say, oh, so you just doubled? You just doubled. Oh, okay. And then double, double 54. We're not even really going to talk about that. Next problem. Then I'll say, okay, how about 8? 8 packs of gum. What are you thinking about there? And again, I'm not going to wait very long because doubling 108 is not too much. Not nobody's going to, but I'll say, oh, so you're just going to double from the 4 to the 8, double the 108. And so is that 216? Okay, everybody, cool. And then I'll just sort of note, interesting that we just found 8 times 27, not by really multiplying by 8 at all, but by multiplying by 2, doubling. Now that's interesting. I wonder if you could think about multiplying 8 times anything by doubling it, and doubling it again. Huh. Interesting. And I'll just kind of just sit there for just a second. Just, okay, that's kind of interesting. Nice. Then I might say, anybody want to guess the next problem? Now, this is an attempt to kind of get people sort of out of the string a little bit, not just out of the string. This is an attempt to get people rising sort of above the idea of I'm just going to do what the teacher tells me. I'm going to do what the leader says, and instead kind of like thinking ahead, guessing a little bit, sort of using not random guessing, but like, well, we doubled. Often people will smile and they think that I'm going to go for 16. Why not, right? We just did 2, we did 4, we did 8, we've been doubling. So then I'll just say, anybody want to guess? I'll pause and then I'll go 10. 10 packs. And then people smile a little bit. They're like, oh, we thought you were going to go 16. It's just a moment where you get to kind of just, get people out of the mode of just doing and kind of, like what might be next. And then they can chuckle just a little bit. Then I'll say, I wonder if there's anything up here that could help you find the number of sticks in 10 packs. Then I'll let people. Now, here's the first time in the string, Kim, where I'm actually going to pause longer than just a second. So now I'm kind of looking, I probably should have said, if I'm doing this problem string with adults, I will probably, before we get too far, and sometimes I forget, and so it gets a little, it might even be here in the string, but ideally it would be sooner. In fact, I think maybe ideally it might be before I even start the string. I might invite everybody in the room. Hey, would everybody just pick up a pencil? Just pick up a pen. Kim just smiled because I said pencil. Pick up something to write with. And then I'll do a little spiel on it's not if you write, it's what you write. So I just want everybody to have something in your hand, because if you want to keep track of your mental thinking as we do this mathing experience, I want you to feel free as you look around, the people next to you, oh, they're writing. Okay, socially, it's okay for me to just jot something down. so that it's not this pressure on the cognitive load. I don't have too much of, I'm not trying to keep all this stuff in my head. I can write down what I need to kind of keep track of the relationships I'm using. It's not if I write, it's what I write. And I'll also say to adults, if you find yourself like mimicking steps that you memorized or that your teacher taught you in second or third grade, maybe in that case, put your pencil down. Maybe in that case, put it down and say to yourself, if I wasn't writing, what would I do? What could I use? Could I use relationships to figure, I could do that? Okay. Once you've got some relationships to use, then pick your pencil back up, keep track of those relationships. Don't just, if you find yourself in mimicking mode, put your pencil down. But if you're keeping track of your mental relationships, totally legal to do that. So having everybody have something to write. So at this point, when I've said 10 packs, some people are writing some things. Some people are just smiling. I'm going to say something like, is anybody interested to use the 8? Did anybody use the 8 packs? Kim, almost always. It is very rare that somebody doesn't say, yeah, I can use the 8 packs, because they're kind of looking up at the table and they're saying to themselves, well, I got stuff I could use. So I'll say, well, how'd you use the 8 packs? And they'll say, well, I got 8 packs and 2 packs. Now I'm going to draw a bracket between the 8 and the 2 on that left side. And then I'll write 8 plus 2 next to it and an arrow down to that 10. So if you had the sticks in 2 packs and the sticks in 8 packs, then you added those together. Yeah. So I added the 54 sticks plus the 216 sticks. So off to the right now, I'm drawing that same bracket, 54 plus the 216, and then a little arrow down. And I'll say, and what did you get? And they'll say 270. And I'll say, oh, did everybody else get 270? A lot of people got 270. Then I'll say, did anybody not use the 8 packs? And someone will smile and say, well, I just added a 0. To which point, then I get to, go off on, did you really add a 0? And often what I'll say is, what mathematically did you do? And they'll say, well, if they don't have words for it, I'll say, are you scaling? Like if you had 10 times the number of packs, now I've just drawn a scaling arrow from the 1 pack to the 10 packs. And then written times 10. If you had 10 times the number of packs, do you have 10 times, now I've drawn the scaling arrow on the right side, the number of sticks? So 27 times 10, 270. Now everybody in the room is like, oh yeah, there's the 0 thing times 10. And I'll say, okay, cool, because there's this times 10 thing in our number system. Your students might not know why that works. You might not know. Maybe we can talk about it later. But for now, because we have it, we're just going to use it. We got this times 10 thing in the 0. We're going to use it. Cool, times 10. Before I go on, right now on my ratio table, I've got a bunch of stuff. I've got those brackets with the 8 plus 2 and the 54 plus 216. I've got the scaling marks from the 1 to 27 down to the 10 to 270. I'm going to erase all of those. I'm going to clean up the ratio table. The only thing left in it are sort of the entries, the 1 to 27, 2 to 54, 4 to 108, 8 to 216, 10 to 270. That's all I have left with the packs and 6 on the top. Now I'll say, cool. All right, next one. Ready? How about 9 packs? I wonder if there's anything up there you could help you. I don't know. Maybe not. Then I let people work. People work. They're circulating. Kim, what do you think the 2 strategies are I'm going to go for here? And any thoughts on which one I'm going to try to get first?
Yeah, I think people are going to use the 8 pack and the 1 pack.
So how could I ask for that instead of just hoping I get it?
That's a good question. So I think you're going to say, did anyone use the 8 pack again?
Again, yeah. And often I'll say, so did anybody use the 8 packs this time? We used 8 last time. Somebody's going to nod. And that's nice. The 8 packs plus the 1 pack. Again, I'm drawing the brackets over on the left. 8 plus 1, arrow down to the 9. Then I'm on the right-hand side, the corresponding bracket from the 27 to the 216. And I'm like, what is 27 and 216? And they'll say, what'd you get, Kim?
Oh, I don't know. Sorry, I wasn't doing it. What'd you?
That's okay.
216.
We're finding the number of 6 and 9 packs, so we're adding either 27 to 216. Is that
243?
243. Cool. Thanks, sir. I didn't want to do the math. Thanks. Or what was the second strategy that people might use?
For sure, they're going to go back to the 10, particularly because it's right above the 9. Somebody will notice that it's so close.
Nice. And so then 10 packs minus 1 pack. Now I'm drawing a bracket between the 10. Oh, I just erased the 8 plus the 1. So that's gone. Now I've got the bracket between the 10 to the 1. So 10 minus 1 packs, arrow down to the 9. Sometimes, Kim, I will actually not do that. I will say, oh, so you did 10 minus 1 to get 9. And I'll just write next to the 10 a minus 1
Mhm.
to get 9. And then I'll say, so 270 minus 1. So you got 269 sticks.
Mhm.
And then I'll pause
Mhm.
and I'll nod and I'll smile. And
Mhm.
people will nod and smile. And then they'll start to shake their head. And
Mhm.
they're like,
Mhm. Mhm.
no. And I'm like, what do you mean, no? So I want teachers to realize I recognize that kids might do that. And I want to
Mhm.
put it up in front of them and go, what are you going to do when a kid does that? What do you, and then some teacher will say, but if you subtract a pack, you have to subtract 27 sticks. And I'll say, oh, if you subtract a pack, you have to subtract all the sticks in that pack. So you can't just subtract one and subtract one. Teachers, when you have a kid that gets in a ratio table and they do the same thing to both sides, but it's not, they haven't stayed proportional, then all you have to do is do experiences like this. When you get in a naked ratio table that doesn't have context, you can literally just say to them, okay, we just subtracted a pack. How many sticks are in that pack? Oh, you remind them of this experience. So now I'm going to do 10 minus 1 with the bracket pointing down to the 9. So now we're going to do 270 minus all the sticks in that pack, 27. Now, at that point, I may ask them how they did that subtraction. We may then go off down to the side, think about 270 minus 27. That would be a good moment for me to sort of support additive reasoning with teachers. In that moment, I will ask somebody, did you think about subtracting 20? I'll draw a number line, 270 on the right. I'll pull out of somebody that they subtract 20. So 270 minus 20 is 250. Then I'll say, okay, we're supposed to subtract 27. Oh, yeah, we got to subtract 7 more. I'll draw a shorter jump of 7. What's 250 minus 7? Is that 243? Yep, that's what we got before. Nice. Then I'll say, I'm kind of curious. Did anybody not subtract 27 as 20 and 7, but did anybody subtract 27 as 30? Then I pause, look. If no one sparks, then I'll say, could you? And I'll wait to see if anybody sparks. If no one sparks, we got more work to do with this group of teachers. Kim, I don't think I've ever had anybody not spark.
Mhm.
Someone in the room goes, well, yeah, you could do 270 minus 30. Now,
Mhm.
I have below that first number line, drawn a second number line, started at the same horizontal location. So the 270s are lined up. Now I've jumped further back than the 20 and the 7, but only a little bit further back. And I've written minus 30. And I'll say, okay, what is 270 minus 30? And they'll say that's 240. Then we have a little fun where I'm like, okay, what are you going to do now? If the person confidently says, well, I subtracted too much, so I have to add 3 back, I'm going to try to catch them saying add, and I'm going to push on that just a little bit. I'm going to go, whoa, 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 we're subtracting. Why are you adding? And I'll look kind of confused. Sometimes people will back up. They're like, I don't know. But sometimes people hold their ground. In that moment, it's very important that I just kind of just look at them like patiently, like, I don't know. What are you thinking? Like, this is we're thinking here. If they back, if they sort of whatever, then I'm like, is anybody agree with them? Like, we're subtracting. Can you add? Somebody will say, well, yeah, you've subtracted too much, so we need to adjust up. So then I'll say, okay, adjust up how much? I'll draw that little jump of 3, and I'll say, okay, here's the hard part. What is 240 and 3? Bam! Hey, look at that. We're at a great place where the question is the answer. And when I land where that jump of adding up 3 should land lined up with the problem string or with the number line above it, so that the 243s are vertically aligned or horizontally aligned. How do you say that? They're in the same horizontal location. They're aligned. They're lined up.
They're aligned.
So that the jump of 27 in both number lines should be about the same. And I'm
Mhm.
purposely trying to make that true.
Before you go on to the next problem,
Yeah.
you asked me, what do you think people will do and what order am I going to be looking for them?
Oh
And you
yeah.
didn't talk
Nice.
about that yet.
Thank
Why
you.
a particular order?
So I'm going to try to pull out of teachers the additive, the add the 8 plus the 1 first, because everybody can latch on to that. Even if they did the 10 minus 1, it'll make sense to them to do the 8 plus 1. If I do the 10 minus 1 first, that has the potential for people to be like, wait, what? But if I do the 8 plus 1 first, everybody's grounded. We're all confident the answer is 243. Now I can introduce this idea that maybe not everybody's thought about. You're like, Pam, are you sure? Yeah, I wouldn't have. So I'm clear I wouldn't have thought of that when I was a young in numeracy. So then I'm going to pull out the strategy that I don't think everybody may have figured, and we get a chance to dive into that one.
Yeah. Also, sometimes in these conversations, you talk about how they use the 8 and the 1 because they happen to be on the ratio table already,
Mm-hmm.
but that many of us can find 10 of a pack, or 10 packs of a thing, and then back up a pack because we
Mm-hmm.
readily hang on to 10 packs in one pack, but not so often do we just walk around with 8 packs.
Yeah, in fact, a way that I'll try to pull out that conversation is to as soon as we've got it all on the board, I'll say, so two great strategies: add the 8 and the 1, take the 10 minus 1 pack. Which of those, if you were walking down the street and bam, you ran into the problem, 9 packs, 27 sticks in a pack, how many sticks? Which of those do you carry with you?
Mm-hmm.
And then we can have a conversation about being lazy. I mean, efficient.
Mm-hmm.
Like you just said, we could recreate the 8 to add it to the 1, but we carry that times 10 around with us. But we want to have that efficiency conversation.
Mm-hmm.
Yeah, with teachers and students. Cool. So we're almost done with the problem string. At that point, then I will erase everything except just the numbers, the 1 to 27, 2 to 54, down to 9 to 243. But all the brackets and the scaling marks, so we've cleaned everything up. And then I'll say, all right, gum, yum, gum. You guys, let's have 100. What about 100 packs of gum? Again, I don't wait very long on this one. I might have people say that number out loud just so people can hear that that number has two names, 2,700 and 2,700. I might take a minute to just talk about how it has two names, but why doesn't 10 times 27 270? We call that 270. Could we also call that 27 tens? I might mention that. But for today's purposes, then I'm going to say, all right, you guys ready? Last problem string. How about 99? 99 packs. Can you use what you know to reason and find the number of sticks in 99 packs? Go. Then I'll let people do that. I'll usually circulate. I'm looking to see how people are doing the subtraction. Kim will also pop in. Leaders, if you have played I Have You Need with your teachers before you do this problem string, you could, right before I did the 99, you could have said, hey, I meant to play a round of I Have You Need with me. Oops, totally forgot. Completely unrelated. Sorry. Hey, just really quick. If I had random, if I had 27, just totally random. If I had 27, how many would you need to make 100? And I'll let people just sort of think about that a little. They'll tell me. In fact, what is that, Kim? If I have 27, what do you need to make 100?
73.
Okay, so I'll just totally unrelated. Sorry, I meant to play I Have You Need. I know we've been playing that. Thanks. Then I'll go, all right, 99 packs. 99 packs go. Now, at this point, there's a couple people usually in the room that smile because they know I played I Have You Need for just a reason there. But then people will say, all right, if I have 100 packs and I'll pull, how did you do it? They'll say, I have 100 packs minus one pack. I'll draw the bracket again, 100 minus one, arrow down to the 99. And then you have to take the sticks. So 2,700 minus the 27. And I'll say, 2,700 sticks minus 27 sticks. I mean, we could do subtraction. We could go over there and borrow, regroup, whatever. But could we think about? And then someone will smile. And I might go represent that on a number line, subtract 20, subtract 7. Leaders, if you've got teachers who've never thought about 2,700 minus 20, this is a good moment for them to think about that. So don't go too fast here. Like let them, I would have, draw the number line on the board. What is 2,700 minus 20? That's good place value work. That's good, like magnitude work. What do these numbers mean? What is 2,700 minus 20? And then subtract another 7. You're feeling that partner of 10 when you subtract that 7. All good stuff to do. If you've had teachers that have a little bit more experience in that moment, you might say, ooh, why did we just play I Have You Need? Can we use that partner of 100 to help us think about 2,700 minus 27? Ooh, there's 100 in there. And if I can think about that 100 minus 27 as being 73, can I think about 2,700 minus 27 as being 2,673? Bam. And we have the number of sticks in 99 packs. And at that point, I might stop the string and just go, y'all, what problem did you just solve? And smile. And they will go, and sometimes they'll say, well, it's 2,700 minus 27. And I'll say, yeah, but why? Why were we doing that? We were doing, and then I'll write down 99 times 27. And I'll say, check it out. You guys just did 99 times 27. Thinking and reasoning, using what you know, using relationships. Well done.
Yeah. Nice. I know we're going a little bit long
This
here,
is
but
a
I'm gonna
long
it
episode.
is,
Yeah.
but I think this is really, really useful. And I'm gonna ask you two questions and then I'm gonna recap.
Okay.
So you started off by sketching your ratio table, and I want you to talk for just a second about when you do horizontal versus vertical ratio tables, because
Mm.
I know people have seen you do it both ways. And is there a rhyme or reason?
Yeah, it's interesting. When you and I started presenting together, I noticed you always did it horizontally and I always did it vertically.
Yeah.
And I had to ask myself why.
Uh-huh.
The reason, so I was doing a vertical ratio table this as I was drawing it here on my iPad next to me, and I will do that when I present almost all the time. In fact, I can't. I'd be hard pressed to think of a horizontal time, only because everything I write almost all the time has a horizontal ratio table,
Yeah.
simply for space.
Yeah.
So in all the books, you'll see a ton of horizontal ratio tables because I need to get more on the page.
Yeah.
So when I present, I'll do it vertically so that I hope people see them both and that you will do both in your classrooms.
Right.
Yep.
And it worked out because you and I presented, then we just had we had both going
We
on.
had both. Yeah, it was nice.
Okay.
Yeah.
Another, I think one last question.
Okay.
Sometimes you do 17 sticks, sometimes
Nice.
27.
Yeah. So again, it was a little of you and me. I always did 27, you did 17, and one day you and I compared. I also sometimes did 37 and 47, but I stopped doing those. There's There, 27 is brilliant because there's times doubling that are just, they go really quickly. And
Mhm.
so I don't have to spend more time than I want to in this string
Right.
doing the doubling. Not so true with 37 and 47. The doubling gets to whatever. 17 is great for younger students or even sometimes teachers of younger students,
Mhm.
but it's not as nice to have the doubling conversation because double 17, there's really, I don't know. It doesn't. You,
Yeah.
there's not as much to talk about. More people have to think about doubling 27. It's easier to double 17. You double 10, you double 7, and you're kind of done. You can double 20 and back up, but almost nobody thinks that's a good idea.
Yeah.
Double 27 is a bit, quite a bit more like whoa. So people are more willing to entertain the doubling. The last thing I'll say about 17 versus 27 is the subtraction. So we end up doing subtraction. If I'm working with people who have had less numeracy experience, it could be, is easier the word I want to use here? It could be an easier inroad, a better inroad, because this, when I subtract 17, I don't have to think about the subtraction as much. But that's a tricky wicket because I also want people to have to think about the subtraction a little bit.
Right.
So I tend to do 27 more often, unless I'm dealing with kids, and then I might do 17.
Yeah.
Yep.
So one of the other things I'll note is that when we did start presenting together, you would set aside this ridiculous amount of time to do this string, and we would argue over like, wait, it's a string. And after several experiences of watching you deliver this string, I was able to step back and say, okay, you're with teachers, with leaders doing this with teachers. It's not just about experiencing the math that's happening. It is, but I just jotted down some things, some conversations, some things that you're able to lob in. The conversation about place value with add a zero and 27 tens being 270. You get to have some conversations about, am I subtracting 1 and 1 on both sides so
Mm.
that sticks and packs? You're talking about a purposeful order of strategies. You lob in the idea of a high have you need. You talk about doubling strategies. You talk about strategies for subtraction, remove a friendly number and remove a friendly number over, and something else. Oh, and talk about why you choose a particular order. So with leaders doing this with teachers, there's a lot of opportunity to stretch it out and to get a lot more meat out of this one particular string, which is why we think it's such a great one to do when you are starting out. Yeah.
Yeah, and I may not land on any of the things you just said very long at all,
Right.
but if they come up a little bit, that's a differentiation thing.
Right.
That's a way that all adults in the room are being stretched a little bit. I'm going to have
Uh-huh.
teachers who don't notice or are able to hang on to most
Uh-huh.
of what you just said, those extra little things that are
Uh-huh.
coming out, but they're doing the math. They're having a good
Yeah.
mathing experience. But I'm
Yeah.
doing all those little things enough that I'm also stretching anybody in the room who's noticing the teacher moves or the cadence or yeah. I'll pop in one other thing. So depending on how much time I've done and who the teachers are, I may throw out one more problem at the end, which would be, now I'm going to put the number on the other side of the ratio table. I've been giving you packs and you had to figure out sticks. Now I'm going to say, what if there were 2,646 sticks? How many packs did I have?
Yeah.
And then that could be one more place that we could go with this problem string that is a brilliant, brilliant extension.
Yeah. All right. So long enough, I think, on
Woo!
Sticks of Gum. It's one
Thanks
of our
for hanging
favorites.
with us on this
Yeah,
long one. Yeah.
for sure. If you would love to see what this string might look like written down, hopefully you took some great notes. But if you'd like to see it, we're going to hand you a lovely download. It is at www.mathisfigureoutable.com/ratio-tables. mathisfigureoutable.com/ratio-tables. And we'll put that in the show notes.
Bam! Y'all, thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Thanks for spreading the word that math is figureoutable. Don't forget, go to mathisfigureoutable.com/DMRK2 webinar. Can't believe we gave you a link that long, to register for the free Developing Mathematical Reasoning Daily Strategies, Tools, and Activities to Teach the Big Ideas in K2 book launch webinar taking place on October 8th. That's mathisfigureoutable.com/DMRK2 webinar. We will see you there.